G'day students. Okay, what we're going to do in this video is teach you about something called like terms, and then how we can actually add and subtract like terms. So we're going to start with looking at some cups. So I've got a cup containing Y beans. Again, we don't know how many beans are in there, so we just call it Y. I also have some extra beans, and there's one of them over there. How many beans do I have if I have 4 cups of beans? Well, let's just go ahead and grab 4 cups of beans. Okay, so there's the answer as a picture. Algebraically speaking, we can say I've got Y beans plus another Y beans plus another cup containing Y beans plus a 4th cup containing Y beans. So the answer is Y plus Y plus Y plus Y. And if you remember back in your primary school days, if you've got 3 plus 3 plus 3 plus 3, for example, you can rewrite that as 4 times 3. So in this case, y plus y plus y plus y can be rewritten as 4 times y or just 4y. So algebraically speaking, if I have 4 cups of beans, I have 4y beans altogether. Okay, what about 3 cups of beans? So we'll drag those down here, and then 2 extra beans. So let's bring in the 2 extra beans. Okay, so we want to write that algebraically. Well, y plus y plus y is 3y plus, then I've got 2 extra beans. So the number of beans is 3 times y plus 2. Now, that can't be written any simpler than that. Some students want to think, well, 3y plus 2, I've got to add something, so I'll make it 5y. Well, that can't be correct because 5y means you have 5 cups. So it turns out it is not possible to write the answer any simpler than that. 3 times the number of beans in each cup is 3y plus 2 extra beans, and that's written in simplest possible way. Okay, we're going to now show you how we can add like terms. So I have 2 cups of beans, each containing Y beans. I don't think I'll bother dragging them. I'll just go ahead and write the algebra. So I have 2 cups of beans, each containing Y beans. You have 3 cups of beans, each containing Y beans. In fact, I will drag them. So I've got 2 cups. You have 3 cups. So there's our cups down there. And I've got 2 cups, you've got 3 cups. How many beans do we have all together? Well, if we put them all together, it's hopefully fairly obvious that we have 5 cups. So 2y plus 3y adds to 5y. And these, as you'll learn, are called like terms because they both have the same variable. And to add them together, we just added the coefficients. 2 plus 3 equals 5. So 2y plus 3y simplifies to 5y. Okay, this time I have 2 cups of beans, each containing Y beans, and I have 3 extra beans. So let's go ahead and it's my little collection. You have 4 cups of beans, and 1 extra bean. How many beans do we have altogether? Well, once again, we have y plus y plus y plus y plus y plus y. So altogether, the number of beans in 6 cups is 6y beans, since each cup contains y beans, and the number of extra beans is 4. So what we actually did, in fact, I'm going to erase that and show the working. My number of beans is 2y plus 3. Your number of beans is 4y plus 1. Excuse me. I'll bracket those. because that's how they were grouped, and I've got to add those together. You don't need the brackets, I just prefer to write it to show how they were grouped. And to work out the total number of beans, 2y plus 4y adds to 6y. 3 plus 1 is 4. So the final answer is we have 6 cups of beans, which is 6y beans plus 4 additional beans. And once again, we can't write it any simpler than that. So notice the shortcut for this, 2y plus 4y is 6y. We just add the coefficients. And then we have the extra beans called the constants. 3 plus 1 is 4. And that is the simplest way we can write the answer. Okay, this time there's big cups containing Y beans, small cups containing Z beans, and then some extra beans. I'll just do the algebra this time. So I have 1 large cup of beans, which is Y, 4 small cups of beans. Well, that gives me 4 Z beans altogether, plus 3 extra beans. You have 2 large cups of beans, plus 2 small cups of beans, plus 2 extra beans. How many beans do we have altogether? Well, we need to add these expressions. And that's really just 1y because it's only 1 cup. 1y plus 2y is 3y. So I've got 3 large cups. 4z plus 2z is 6z. And the extra beans, 3 plus 2 is 5. So here's the secret for adding like terms. I can only add the terms that have the same variable. So I can add 1y plus 2y to get 3y. I can add 4z plus 2z to get 6z, and I can add 3 plus 2 to get 5. And once again, we can't write it any simpler than that. We can't add the 3 and the 6 and the y and the z because it doesn't make any sense. It turns out subtracting is very, very similar. I have 6 large cups of beans, so that's 6y. I have 4 small cups of beans, so that's 4z. And I have 6 extra beans. Now what I'm going to do is I'm going to give you 2 large cups of beans. I'm going to take away 2 large cups of beans. I'm going to take away 3 small cups of beans. And I'm going to take away 1 more bean. So when I do that, once again, I can only add and subtract the terms with the same letter part. 6y take 2y means I've got 4y beans. I got 4 cups of beans. 4z take 3z. I've got 1 cup, 1 smaller cup of beans, and I had 6 extra beans, and I've given you 1 means I've now got 5 extra beans. So the expression for how many beans I have left is 4y plus z plus 5. So once again, for subtracting, I can only subtract terms that have the same letter part. 6y take 2y is 4y, 4z take 3z is z, or 1z, and 6 take 1 is 5. And the final answer can't be written any simpler than that. So finally, all this is to build up to the idea of what like terms are. And here's the definition. I suggest you write this down. Like terms are terms that have the same variables, x, y, or z, raised to the same powers. And what we sort of learned in the last couple of slides is we can only add and subtract like terms. So, are 3y and 4y squared like terms? And why or why not? Well, the letter part here is a y, but the letter part here is actually y squared. So this is really 3y, and if I write this out in expanded form, 4yy. So I can't add those together. They're not like terms because the letter parts are not the same. The variable has to be the same, but the power has to be the same. So in this case, the answer is no, because the powers on y are different. What about 6mn and negative 2nm? Well, here the letter part is m times n. Here the letter part is n times m. But keep in mind, because we're multiplying, we can rewrite that in a different order. So that is really 2mn, that's 6mn. The letter parts are the same. So the answer is yes. And the reason is it's because we have the same variables raised to the same power. So if we're multiplying, the order doesn't matter. Looking at the next one, here I've got h or h squared. Here I only have a single h. So because the letter parts aren't the same, the answer is no. The k's are also different. Here I have a single k. Here I've got k squared or k times k. So for that, those two expressions, they are not like terms because the powers are not the same. And let's look at the last one. Okay, this contains the variable f. This contains the variable f. This one contains the variable p. This one contains the variable p. This one contains an m squared. That one contains an m squared. So the letter parts are the same, even though they're in a different order. Order doesn't matter when you're multiplying. So the answer for this one is yes, and it's because the letter parts are the same.